have just completed hg, which is geometric altitude. We have talked about HA, which is measured from the center of the Earth, which is called absolute altitude. We have also defined something H, which is fictitious altitude, which is also called geopotential altitude. And we have seen that Hg and H are not much of a different if height is within 60 kilometers, because we have seen even at 65 kilometers, the error we commit is around 1%. So these are three types of altitudes are used in defining the atmospheric description. Okay. There are other important altitudes you will find which we need to know. One is pressure altitude. Density altitude. Then temperature altitude. What are these? And the principle of altimeter is it senses the static pressure locally at that altitude, and that pressure is calibrated and some number is recorded, right? Either through analog or through a digital, right? But that is not the pressure altitude. Suppose, for example, an airplane is flying at some altitude x, right? And it is sensing pressure, static pressure, let's say around 6.16 into 10 to the power 5 Newton per meter square. Right? Now what is the pressure altitude? Pressure altitude is, now you go back to the standard atmosphere and see what is that altitude at which the pressure is 6.16 into 10 to the power 5 Newton per meter square. So that becomes the pressure altitude, and that you will find is roughly equal to 4 kilometers. Are you clear about pressure altitude? Let me repeat. Now we are discussing about pressure altitude. Suppose I am flying at a geometric height hg and my instrument is sensing pressure equal to 6.16 into 10 to the power 5 Newton per meter square. The pressure altitude is defined in this way. What is said? Okay, this is the pressure sensed by the instrument at a altitude hg. Now you go back and look on the standard table. What is that altitude which corresponds to this pressure? And that altitude, let's say it is around 4 kilometers if you check. So this pressure altitude becomes 4 kilometers. So pressure altitude is 4 kilometers. Right? Now, come back to temperature altitude. When you are sensing a pressure of 6.16 into 10 to the power 5 Newton per meter square, you put some instrument which can measure temperature, and let's say that temperature is T star at that altitude. But what will be the temperature altitude? Now once you have noted down this T star, the temperature measured by the instrument at that altitude, come back to the standard atmosphere table and see what is that corresponding altitude at which the temperature is T star, right? So that becomes temperature altitude. Roughly for this case, it may become 3.5 kilometer or any other numbers, right? Why I am writing difference is, please note that although the airplane is flying at same geometric altitude, the pressure altitude and temperature altitude are different. Is this part clear? Because what is temperature altitude? Actually, you measure the temperature outside here, and then look back to the standard atmosphere table to get that temperature, what is the altitude the airplane should fly. So that is not the 4 kilometer, that could be something different than 4 kilometer. I'm just putting a number 3.5 kilometer to stress this point. The temperature altitude and pressure altitude may not have the same number. And now if I ask what is the density altitude, we all understand. Rho equal to P by RT. So you know what is the pressure you are sensing, actual pressure. You know what is the temperature actually you are sensing. You find what is the density by using this relationship. Let's say it is rho star. Now to get the density altitude, I have to again go back to the standard atmosphere and see this rho star corresponds to what altitude, and that is called density altitude. Again, that may not be 3.5 or either 4, that could be anything other than this. So what is the point I'm stressing? Even if you are flying at same geometric altitude, the pressure altitude, the temperature altitude, and density altitude will not be same, right? And that altimeter, you will see some video on this. Altimeter actually gives us the pressure altitude. They are calibrated like that, okay?
Altimeter is the instrument which tells us the height above the sea level. So here you can see this is an altimeter which is this gauge is calibrated in feet, and this is calibrated up to 20,000 feet. This just takes up the static pressure. Like the airspeed indicator, once I just told you, it takes both pitot and static pressure, whereas altimeter just takes the static pressure. The static port of altimeter can be seen. This is the static port. It's just this blanking is removed, and this is the static line from where the static pressure goes in. 3 needles which can be seen on the gauge. The smallest one, the intermediate, and the longest one are there for indicating the altitude in different thousands of feet. Like the smallest needle gives the reading in tens of thousands of feet. The intermediate one gives the reading in thousands of feet, whereas the longest needle gives the reading in hundreds of feet. And the Boltzmann window, that is used to set the barometric pressure by the knob, so that the pressure can be related to the atmospheric pressure when the aircraft is flying. As the aircraft goes up, the pressure decreases, which shows up by the increase in altitude in the gauge.
We have another important parameter, variable we should know before we interact with the atmosphere, and that is the speed or velocity which is relative to air, right? Air, or we say air relative speed of the airplane. Because you have understood that if I want to lift, as per George Calais' explanation, I need to move this in such a way that there is a relative speed between the wing or the plate and the air or the atmosphere, right? So aerodynamic forces, they will depend upon the relative air speed. Just to explain you, if this machine is grounded and moved on the ground, and if there is an air speed indicator, and if there are no winds blowing, this airspeed indicator will give a 0 reading. But if suddenly wind starts blowing, even if this airplane is not moving, the airspeed indicator will give some finite value of the speed, which will be the wind speed, right? So let us understand how airspeed is sensed or measured in an aircraft when it is in motion or when it is in ground. So I'll give a title, measurement of air speed When I say airspeed, keep back of your mind, for flying we are interested in the air relative speed of the airplane. Before we understand this, let us revise something which is very important. One is static pressure, another is total pressure. The static pressure is primarily because of random motion of the molecule which impinges on your body, and there's a momentum transfer, and that gets converted into pressure, which is static pressure. When you try to understand about total pressure, imagine a stream of fluid is flowing, right? And you want to stop this fluid motion very slowly, and then what sort of pressure you will feel is what is total pressure, right? In aeronautical term or aerodynamics term, we said you bring that fluid motion into rest isentropically, that is, there are no losses. Total momentum is transferred into force, okay, through pressure. So, and if you recall, I can always write P total is equal to P static plus half rho v square, which is the dynamic pressure. Let us see what is the difference between static pressure and total pressure. This is nothing but half rho v square. So the difference between total pressure and static pressure is nothing but dynamic pressure. I am referring to low speed incompressible flow. So whatever now we'll be using, keep that back of your mind. I repeat again here, total pressure is static plus dynamic pressure. So difference between total and static is nothing but dynamic pressure. If I want to find the speed, I know if somehow I can get this difference between total and static and density at that point, I can get what is the speed. Okay, that is the basic concept. Okay, let us see what is the problem here and how this concept can be utilized. Very popular instrument that is used, Pitot's tube. Where the principle is very simple. Watch out here, there is an opening. So the fluid particles are moving like this, right? So what will happen? This point will sense the static pressure, and this input goes to the chamber. Let's say here I am sensing static pressure. And now what is happening here? The fluid which are going inside like this, they come to rest here, right? So this part will be sensing total pressure. That is, I told you total pressure, the whole fluid is brought to rest isentropically. So they are brought to rest here. So this is total pressure. So what is the difference between these two? The difference is nothing but dynamic pressure half rho v square. And let's say this is a diaphragm. And which is sensitive to the pressure difference. And schematically I put a pointer, and if I calibrate that pointer for difference in total and static pressure, then I can measure this P0 minus PS, right? So this is the concept that is used to measure or instrument the difference P0 minus PS. But the problem is on rho. At every altitude, I cannot find out the rho so easily. So what is done is, when I calibrate this airspeed indicator, we make an assumption. We use V as 2 delta P by rho naught. That is sea level condition. Okay? And we term it as VE or equivalent airspeed. What is the physical meaning of this equivalent airspeed? It is, suppose an airplane is flying at this altitude, say some altitude Z, and it is sensing the differential pressure delta P. Possible? That is, I am flying at altitude Z and the instrument is sensing the differential pressure delta P, which is nothing but the dynamic pressure. I am flying at this altitude and I am sensing the dynamic pressure at that altitude. What is equivalent airspeed here? If I fly at sea level, I am flying here, now I fly at sea level and duplicate this dynamic pressure. That is, I fly at sea level and duplicate this sea level, and that speed is called equivalent speed or VE by notation. Right? So what was this? This was rho true and V true. So I write rho true, V true. This is the actual dynamic pressure which was sensed by the airplane at a given altitude. And when we are defining equivalent airspeed, we said, you ask a question to yourself, to duplicate the same dynamic pressure, if I fly at sea level, what will be the equivalent airspeed? So you could see now, this equivalent airspeed will be, the half goes cancel, see rho true by rho sea level under root into V true. So the airspeed indicator will be giving us V equivalent. Whatever instrument they are installed in the aircraft cockpit, they actually give V equivalent because that is the speed which is being read through an airspeed indicator where rho equal to rho naught has been used and the graduations are made. Okay? However, it's not difficult. If I know V through airspeed indicator, if I know true density at that altitude and sea level altitude or sea level density, then I can easily find out what is the true airspeed. This relationship, let us again see. The airspeed indicator will give us equivalent airspeed. So, but if I want to find out what is true airspeed, I simply want to know what is the density of air at the altitude the airplane is flying and what is the density of air at sea level. With this ratio, I can find out true airspeed once I know equivalent airspeed. Okay?
Pitot static instrument is the primary instrument of the aircraft. Pitot static system comprises of the altimeter, ASI and vertical speed indicator, which uses static pressure and pitot pressure to indicate the altitude, vertical speed and with respect to time and the airspeed of the aircraft. So you can see this is the airspeed indicator. It takes two inputs, the pitot pressure and the static pressure. The pitot and the static port. Through this the air pressure goes inside and the difference of pressure is measured through this diaphragm by expanding or retracting it, and then through the coupling element, that is the gears, the mechanical linkages, the reading is given to the indicating element that is on the gauges. Airspeed gauges are calibrated in knots. The difference of pressure when the diaphragm moves is shown on this gauge.